Normally on the
Oh,
you clicked already.
shoot.
Oh well, it's fine. Don't worry about it.
Okay. All right. Hi, everybody. I'm Connor, as you can see, and we're going to learn about Git. And yeah, so I'm a senior here, and I graduate in December. I have a lot of experience with Git, so hopefully I can shed some of that experience to you in a really very understandable way. And how we're going to do that is we're going to start with, well, if I could change the slide. Okay, so we're going to start with talking about version control systems, then about Git, and then GitHub. And then we're going to do a mini command line tutorial because we're going to be learning how to use Git on the command line. And then we're going to go through a tiny project of making some commits to GitHub and kind of just the process flow of doing a project in Git. So have any of you used Git before GitHub? Okay, perfect. So a little bit. So yeah, so I'll start out from the very beginning of what a version control system is. And a version control system is, well, as you can see, it's a system that records changes to a file or set of files over time. So with that, you can work collaboratively with people. You can blame others when other people break your code. And it's very similar to how Dropbox works. So if you use Dropbox or Google Drive, you can see the history of your edits. Git is exactly the same way. You can see the history of what you've changed. And you can go back and revert back to that, or you can analyze what you did in the past. So some benefits of why to use it is things that I've actually encountered is where I'm working on something where I thought I needed it and I didn't realize it until 3 days later. Without using Git, I would have not had my code anymore and would have had to gone back and rethink exactly what I did. But thankfully for Git, I could just do a Git revert and I went back to my old code. Another reason you're working on a group project, all your group members can work on it at the same time, back up your code at the same time, and none of you don't have to fight with each other over who edits what file or send files back and forth. Or you lose your computer crashes and you lose your code when it's due in a few hours. That's happened to me as well, but thankfully it was on Git and I could save it. And also if you want to work in an internship, it was very good on your resume to know how to use Git. Almost every company uses Git. If they don't use Git, then they use some other form of version control. So very important to learn. So Git specifically is started in 2005 by Linus, not Linux, Linus Torvalds, to help with Linux development. And there's different kinds, like I said, Subversion, Mercurial, but the most popular is Git. So what is Git then? So with Git, you have these repositories, and in those repositories is essentially a folder on your computer where you work on your code. Like when you're working on your code, you have it all in a source folder. So you have that source folder, which is now a repository, which is tracked. And every change you make that you save is tracked in that repository. Every single keystroke you make that you save. And then what you can do is you can have that repository on a remote server, which you can then send the code to and have that source folder on there. So as you can see here, multiple people are working on the same code, and then they put it back onto a remote server so everyone can store there. And that remote server that we'll use is GitHub, which allows you to host your code online. So, like I said, you can make a copy of the code base on your local machine, make your changes, break things. It won't affect the other people that are using it until you push that code up to the GitHub repository. So that was a very quick intro. I really want to get into just doing it because I think that's a really good way to learn it. Is there any questions so far? Okay, then how many of you have like experience using the command line at all? Okay, good. So if you're on, we're going to do a really quick intro to command line. So if you're on a Linux computer or Mac, then you can type this command in your terminal if you open terminal. And if you type ls, it shows each folder in that directory. If you're on Windows, the same command is dir, D-I-R. So go ahead and try that right now. It'll show all your directories and files. Similarly, you can use cd to switch into a folder. So I was in that folder there. If I type cd and then the folder name, it takes me into that folder, as you can see, and it shows my current folder. And then finally, an important command for this is pwd, which shows the current directory that you're in. I don't think this works on Windows. You know what the equivalent is on Windows?
If you install git bash on Windows and all the commands match.
Yeah, I'm not sure if everyone did that. But yeah, so pwd will show the current directory you're in. So with those three commands, you can navigate around your computer through the terminal, and you can do all kinds of fun stuff. And then next, And so these are the commands we're going to use. And you won't understand these commands yet, but you will by the end of this. So I'll come back and reference this as I'm going. I'm not going to talk about it just yet until we start. But yeah, so we're going to start now. And if you want to follow along, you can. We're going to go to GitHub right now and create a new repository. So let me zoom in some. So if you're logged into GitHub, and you should all follow me, see Landry94. You can click this button here, which says New Repository. And so now we're on this screen to create a new repository. For this, we'll just call it Supplements 2. Very fitting name. You can add a description if you want, and then you can choose whether it's public or private. And then you can also choose to initialize it with a README. A README is just a text file that explains your project. So we'll go ahead and add that in there. And then a git ignore is a file that's added to your Git repository that causes Git to always ignore certain file types. One of the key things to do with Git is to never include compiled files in your Git repository because it won't work on other people's machines. So this tutorial, we're going to use Java. I can just click this, and now I can click Create Repository. So now on this repository, we have a readme.md file, which is marked down, which is like a fancy text file, essentially. And we also have this git ignore folder, or git ignore file. So here we can do like anything we want. We can upload files, you can create a new file, but you can't really code very well in GitHub. It's better for just browsing. So what we're going to do is copy this repository we created to our own computer. So in this button here, clone or download, we're going to click on that and copy the link. And now, once we have that, we're going to move back over to our terminal, which is over here. Can you guys see this okay? Is it too dark or too... Okay. So now that we're in here, we're in our terminal. So the first command, whenever you're using GitHub in the command line, you're always going to start anything you do with the word git. So if I just type git, then so if we just type git, then it lists kind of like a help page. So if you're ever confused while using git, you can just type that word and press enter, and it will show you kind of a short description of each of the commands. So what we want to do is we want to clone the repository, essentially copy it directly from the server. So we're going to type git clone and then paste that URL. And so now that that's there, we can press enter. We're going to get some output. And so what it's doing now is it's cloning it there. It's some output saying what it's cloning, how many objects, files it's cloning, and then it's done. So now I'm inside this folder. If I type ls, I have a new folder here called Supplements 2, which was just copied in, which wasn't there before. So now if I type cd, and I type Supplements 2, now we're inside that folder. As you can see, also I added this just for help, so you can see kind of like I'm my user in this prog/supplements2 folder on git master, and you'll learn what master is soon. So we're in this git directory. If I can see my readme.md file that's there now. So now's where Git kind of gets confusing for some people until you practice with it. So I'm just going to draw some stuff. So how Git works is, or is anyone familiar with how graphs work or any kind of graph theory? Of course you are, Jake. But so yeah. So a graph is essentially a set of nodes or points that are connected to each other by lines in the most simplest form. So whenever we created this Git repository, we created an initial node. So we can go and like draw a node here, which that node contains the readme.md file and the .gitignore file, which you don't see here because it's a hidden file. So we have this readme.md file in our node here. So that's our initial history. But we want to add something to our project instead of just a text file. So we'll go over here and write some Java code, which I've already written a little bit for. And let's just do something basic like system.out.println. Just a basic hello world. So we'll save that. And we know what that does. It just prints out hello world, so I don't really need to compile it. But now, if I'm in here, if I press enter again, well, I have to save in the right directory. And you can write any kind of file you want for this. It doesn't have to be this Java file, but you can make it the Java file if you want. So I'll save this supplement.java file. And now if I press enter, we can see that this circle has changed to an X. So what that means is Git detected changes because there's a new file. So now typing back the Git command, I can see this certain command called git status, and it shows the working tree status. So if I type git status now, then I can see that I'm on this master branch still, and that I'm up to date with my GitHub repository, which origin/master is the GitHub repository. Now there's this untracked file though, and it kind of has a helpful tool, helpful tip for git add and then the file name to include what will be committed. So I'm gonna go ahead and do that. And go ahead and do git add supplement.java. Is everyone following along so far? Any questions? Perfect. So I added this git add supplement.java, and now if I type git status again, I can see changes to be committed. So it's changed, and there's a new file, supplement.java. If I don't want that anymore, I can use this command here, git reset head file name, but we don't need to do that because we want to commit this. So at this point, we've kind of, in a way, added a file to a staging area, which are the files we're interested in. If we don't add files to the staging area, they won't be included in our commitment or saving of our current state of the Git directory. So at this point then, again, typing git, we can see the commit command there underneath branch and checkout, record changes to the repository. So once we do that, it's going to create a new node, which will be connected and have that supplement.java file in it. So I'll do git commit, and then for every commit you make, you have to add a message. So we'll add -m, and we'll say added a new file, or added so important thing about git commit messages is you want to be descriptive about what you're doing. You don't want to just have like a commit message that's like, LOL, I broke something, because it actually is not descriptive at all about what you did, and you probably don't want to commit something that's broken. So we make this commit with the message, and we press enter, and we can see one file changed, 5 insertions because we added 5 lines of code, and it adds this weird like short number. Every single commit is going to have a number added to it, which is called a hash, a SHA-1 hash specifically. So now this commit is real, and we have a history. For example, if I type git log, then I can see my initial commit there, and now I can see my commit with the message. And now there's those 2 different nodes, and they each have their SHA-1 hash. So typing git status again, we can see now that we're ahead of origin/master by 1 commit, which means that our local repository is ahead of the GitHub repository. And to fix that, we have to set git push, which will upload those changes. And so they don't say it here, unfortunately, but whenever you type git push, you should always specify where you're pushing. So whenever you make a new GitHub repository, GitHub is going to be origin, the word origin to git. So git push origin, and then the branch name, which we're on master, so we will type master. And it wants my password. I don't remember that. Okay, well, let me fix something real quick. Normally I clone using the SSH URL, which I have these files stored in so that I don't have to put in my password. So all right, now let's see if we can push to origin master. Perfect. Okay. So now we're back to where we were before. So git push origin master, push it to GitHub, and push it to the master branch. So we wrote those objects with some output, and then we can see that we're here. It's on GitHub now. So if we go look at GitHub, we can see, if we refresh the page, our new files there, supplement.java. And everyone can see it. They can see our changes. And I can actually go look. I can look at the number of commits. And you can see it there too, just like when I did git log. Is there any questions so far? Everyone's got it? Perfect.
One question.
Yes?
What are the pros and cons of having HTTPS versus SSH?
So, I mean, they're both fine. It's really just preference. One of the benefits with SSH is you can use an SSH key with it, so you don't have to enter in your password. I'm not going to go into that, but SSH key is essentially like a security key so that it automatically verifies it's your computer. So yeah, it honestly doesn't matter which you use. If one doesn't work, then try the other, like I just did. So yeah, so now the problem with what we're doing here, though, is that we were committing directly to the master branch. And so this is master. But if everyone's committing to the master branch, you can't have people commit there and then you're coding, then you commit something, but you don't have the changes that are already uploaded. It turns into a mess, which is where branching comes in. So branching essentially splits the tree that we've created, or this graph that we've created, into another branch. Since if this was a tree, then a branch would stick off like this. And we can create a commit here. So let's say a branch add, I don't know, method. So I make this branch called add method, and this branch is logically separate from our original code base, which means we can do whatever we want. We can push whatever changes we want to GitHub, but it won't break master, which should be working code. So we'll actually go ahead and do that. And so just having git status again, we're up to date, nothing to commit. We wouldn't want to do this if we had unstaged changes. So we're going to create this new branch using git checkout. And what checkout does is it checks out a branch, and if the branch doesn't exist, then we have to add -b and then the branch name. So we're going to do add method. And now we're on this new branch. And you can see now that this changed from master to add method. So we're actually on this side of the logical code now, so we won't break master. It's very good. And now we'll go ahead and add just something like, and we'll copy this over here instead, and then we'll call the method. Not hell. So now we have that, and we have this branch. I can see that it's unstaged again, so we have to just do normal git add supplement.java. And this would apply to any file. Like if I had a bunch of files in there, it would list all of those files. And if there's a bunch of files, then let's say add another file. So I'll just do an empty file. So now there's these two files, new files on track. So I want to track it. If I want to do that, I can just take care of everything without having to think about it by just doing git add and dot. And if you do git add and dot, then everything gets added to the tracking. So now we can do this. We can go commit. And then we'll go ahead and commit that, just like before. And then we can do exactly the same. We can do git push origin. But now that we're on this other branch, we have to do the branch name, so add method. Exactly like before, the same process. There's nothing, the flow is not very different when you're on a different branch. But now that we did this, we can go look on GitHub again. And we can actually see that we have this new branch, add method. So if I'm on GitHub, I can go over here and not break stuff while someone else is working on master, or there's like a billion other different branches that people are working on. But now I'm at a point where this is finished. I have like a couple commits on here, and I want to merge it back into master because I have working code that I want in our project. So now we're going to merge that branch back in, which is where things can get kind of crazy sometimes. But for the most part, it should be straightforward because Git has auto-merging tools in it that'll combine the files together if there's differences. And only in rare cases will you have to actually fix a merge conflict, which I can make that happen, and we can fix that. So what we're going to do now is we're going to essentially merge this back in and make a new commit where it merges. So I'm back on here. I want to check out my master branch. So I'm up to date with master still. Nothing to pull because I didn't actually change master. And I want to bring that in. So if I type git merge, well, so git merge joins two or more development histories together. A development history is just another branch. So we can type git merge and the branch name. If we press enter, then it says fast forwards the branch, which means it's fast forwarding the history here into this new node, and then creates a new commit, which has that new updated this SHA from here up to this SHA, which is here. And so now we have that, and we're now out of date. Because of that, we're ahead. We can push that to master. So now I can go back to GitHub, and we're on master, and we have that new stuff. And we can actually look over on the graphs tab of GitHub, and I'm pretty sure, I think it's network. Yeah, so Michael actually made his own branch on this repository. But you can see like my history and his history on branches he's made. And so everyone can work on their branches, but I didn't even notice that he was making commits or pushes to different branches because they're completely separate from what I'm working on, which is kind of like the joy of Git and GitHub. So now let's, the last final thing really for a Git workflow is what happens when you have a merge conflict where, say I write code to, can you actually, Michael, can you make a commit to master?
I probably already did.
Okay. Add code, can you like make sure that you added code to master though, like edit a file? Actually, I'll just take care of it.
Check the my first pull request.
Oh, you made a pull request.
3 pull requests.
Okay, we won't do that. I don't want to go into that because it's kind of crazy here. But so there's this hello.txt. Let's say I edit that on here. So let's say I just say this is a supplement. And so I can actually make these commits on GitHub as well. So I'm about to commit to master on GitHub by editing that file, and then I'm just going to leave the default message and commit it directly to master. So there's this new commit on there, and hello.txt is different than my hello.txt. So if I go and I output the contents of hello.txt, there's nothing there. The command cat outputs the contents of a file. There's nothing there, but I don't know that the master changed, but I'm going to make some changes to my hello.txt on the master. So open that. So I'll say this is going to create a merge conflict and save it. I go back here, I can commit those changes. Also, another thing with Git is it'll know if you make a typo. Did you mean this status? And now I have this. I have this commit, but then I go to push. And if I do a git push origin master, then it's going to be like error, failed to push some references. They're rejected because there's work that's done that you don't have locally, because I forgot to do a git pull before I made my changes. And you always want to do a git pull before you start making your changes to make sure there's not something that you're missing, or else you're going to run into this. And it just kind of throws you out of your flow, but you have to fix it because it just can't happen. So I'll do that, but there's a conflict, a merge conflict in hello.txt. It can't automatically merge it because if you have different contents in a single file, then it's not very good at detecting those. If you can solve that, then you'll make a lot of money doing computer stuff. So if I go back here, though, this text file changed. So I had this extra commit here that I added, and this is called head, the most recent commit. So the contents here are my head, which is what I added. But the ones previous were that hash of one commit directly prior, which is this is a supplement. So I have to decide what I want. If you're in Edge code, it'll show this, and you have to just choose the code that you want. And it can be kind of complicated at times, because if you don't know what's in the other commit, you'll see a bunch of random code that's not yours, and you might break something. But in this case, we just want to delete everything except we just want to keep what we had. So we'll save that. And you just remove those extra added things and save your original work. And you can do exactly like before. You just add and we made that commit, and now we can finally push back to master, which we're now behind by 2 commits because we made a new commit fixing that merge conflict. So yeah, that is why you work on a branch, because if you don't, someone else is going to contribute to your code and break it. So yeah, just to kind of go over that again, git clone will copy a repository from GitHub to your local machine. Git status will show you what's going on. Git add will add your files you want to commit from that staging area. So if you look, what you're working on is your code here. If you add it, it adds it to the staging index. And then git commit will actually commit it to your local repository. Git checkout will switch from one branch to another. And then git merge will merge that branch. And then also git push will push it to the remote repository, and git clone or git pull will pull stuff from the remote repository, which in our case is GitHub. So yeah, what time is it? 6:49. Okay. Are there any questions about everything I've covered so far? Everyone gets what's going on? Yeah. Yes. So yeah, I highly recommend using this in all of your projects that you do, because you're going to be using this at a company, and if you can go into an internship or a job and you know how to use Git already, they're going to be like, wow, this person's really good at what they do. We should get them a full-time offer and pay them more. So essentially did this, and further resources, highly recommend checking out the Git guide at this website. It goes really in-depth. Git's an incredibly complex program. We barely scratch the surface, but there's all kinds of things you can do. You can actually, there's commands in Git to find like where a bug was introduced in your code through hundreds of commits. There's different commands to cherry pick results, which is really weird. There's all kinds of merging things. You can have branches from branches. Like I could have a branch over here and then a branch over here, but commit here, and then another commit, and then here, and then like merge that back into here. Like you can go crazy with Git, and there's all kinds of stuff. Do more tutorials. Try.github.io. It's like a follow-along tutorial of Git, a bit more in depth than this. And then finally, the GitHub Education Pack. If you don't have that yet, sign up for it with your UF email because you get all kinds of free stuff. I'm actually going to go there now because it's honestly amazing. So you don't get a backpack, unfortunately, but you get access to all this AWS stuff, Datadog, DigitalOcean, bunch of school education stuff, Microsoft Imagine, all this for free, which is normally like a couple $1,000s. You just have to go to education.github.com/pack, and then you click Get Your Pack. Or you can look up GitHub Education Pack. So yeah, if anyone wants to learn any more complex stuff with Git, feel free to stay after and ask me questions. But
Any questions right now?
yeah, any questions right now? I can
But private repositories on GitHub, so GitHub allows having private repository while we are students.
Yeah. That's actually part of the GitHub Education Pack. If you get that, you can have private repositories if you don't want to show your assignments, because you can kind of get in trouble for having your assignments public on GitHub by UF.
But have you ever worked on like Bitbucket, because I think they provide?
Yeah, Bitbucket, they provide unlimited private repositories for free, I think. They're another similar host like GitHub, but I don't know. GitHub seems to be the most popular, so yeah. What's up?
You're going to post the PowerPoint on Facebook?
Yeah, I'll post that, and I'll also post a little bit describing the flow of how to do it and stuff, like from my terminal. So yeah.
Can I say one thing also?
Yeah, go ahead.
I would suggest from here on out, since you guys know how to use Git, try and save like all your school work and stuff on there, because in the event of a disaster, you'll have everything still on GitHub.
Yeah, because if you stop using Git, then you're going to forget how to use it, and then it becomes harder, and you just get to keep on using it for everything. So hopefully you guys understand how to use Git and GitHub now. Thanks for coming.
Good.
And
Yo, Connor, can you go on your thing and do my the last pull request I did?
the what?
Last pull request. I put the announcements as a pull request. The closing one. Just
What?
go to file changes or merge or file changes. So yeah,
So.
announcements.
Hey guys, my name's Ray Oliva. I'm the Director of Supplements here for FTP, and I want to say a quick thank you to our own Vice President, Connor Landry, for this awesome presentation. If you haven't already, if I could just have a minute of your time, please be sure to sign in at this link right down here on the board. Also, if you're interested, we are having another compliment session next week on Thursday at 6 o'clock. Which room is that again?
6:15 and lit 221.
6:15 and Little 221. I should probably look at these. Also, ACM is going to be having our first general body meeting of the spring on February 2nd at 6:15 and CSE 222. And if you enjoyed these supplement sessions, we're going to be having another one with UF DOS Club February 10th, which is 2 weeks from now, same time, and we are not sure 100% on the location yet.
What's
And
DOS?
DOS is the Digital Arts and Science Club. Thank you, Michael. And then the last thing I want you guys to know is ACM is having their Friday Night Hacks event right now. Tonight is a special board game edition. Please be sure to go by, have some pizza, hang out, meet new people, be a part of the community, and play some board games. Hope to see you guys there, and I hope you guys enjoyed.
Be nerds with us.
Yeah!
Do you like my closing?
Yes. I should stop. Yes.
I said, I love you, Ray.